Okay, so this is the 2025 Higher Level Maths Leaving Cert Paper 1, question 9a. Danny drives a car. The fuel consumption F of Danny's car depends on the speed of the car C. For one particular journey, F is given by F of C is equal to 0.05 C squared minus 8.5 C plus 800, where F is in litres per 10,000 kilometres and C is in kilometres per hour, and C is between 40 and 120 inclusive. Show that there is no difference between the fuel consumption F when Danny's car is travelling at 60 kilometers per hour and when he's travelling at 110 kilometers per hour. Okay, so all we got to do is put 60 and 110 into our formula. So we need to find F of 60 and we need to find F of 110. So we're going to do 0.05 times 60 squared minus 8.5 times 60 plus 800. When you do that, you get 470. And this is the fuel consumption. So this is litres per 10,000 kilometers. So now we just got to put in 110. So it's 0.05 times 110 squared minus 8.5 times 110 plus 800. When you do that, you also get 470 and it's litres per 10,000 kilometers. That's it for part 1. Okay, let's look at part 2. Find an expression for dF/dC, the rate of change of fuel consumption with respect to speed. We have F of C is equal to 0.05 C squared minus 8.5 C plus 800. So all we got to do is find F prime C, or dF/dC, which is equal to 2 times, you bring the 2 down, multiply by 0.05, so that's 0.1 C, and then it's just minus 8.5. That's it. Okay, next question then. During part of the journey, the speed C of Danny's car at time t is given by C is equal to 78 plus 9 log t squared, where t is the time in minutes. So t is between 1 and 10 inclusive, and c is in kilometers per hour. And c is in kilometers per hour. So we're putting minutes in and we're getting kilometers per hour out. Okay, use this and your answer to part A3 to find the value of dF/dC when t is 7. Give your answer correct to 1 decimal place. Okay, so we know that F prime C, or dF/dC, is equal to 0.1 C minus 8.5. This is just dF/dC. We did that earlier. Now we know that C is equal to 78 plus 9 log t squared. We're given that up here. So what we've got to do is put that in instead of C. So it's 0.1 times 78 plus 9 log, and it's t squared, minus 8.5. So I've just put it in there. Now then, at t is equal to 7, we've got dF/dC is equal to 0.1 times 78 plus 9 log 7, which we have to square, so that's 49, minus 8.5. So when you do that, you get 2.802638 and so on, and that's approximately equal to 2.8 to 1 decimal place. I think we have to do this to 1 decimal place. Yeah. Now the problem here is, I think the hardest part of this is trying to figure out the units. So remember, this is dF/dC. So F is the fuel consumption, and that is in liters per 10,000 kilometers. And then dC, that's the speed, and that's in kilometers per hour. So it's all of this in kilometers per hour. Now you could try simplifying that a little bit, but I think I might just leave it at that. Okay, next part. Let's see. Show that the rate of change of the car's speed with respect to time is given by dC dt is equal to 18 over t. Well, the speed, C, is just given by 78 plus 9 log t squared. So we've got to find dC dt. So if you differentiate 78, you'll get 0. If you differentiate this, then you will get 9 and then log t squared. So you've got to use the chain rule here. If you differentiate the log of something, it's just going to be times 1 over that something. And then because this is not a t, it's a function of t, it's a t squared. You've got to differentiate t squared as well, so that's times 2t. So this is my answer here. So dc dt is equal to, well, 2 times 9, 18. I've got a t on the top, I've got a t squared on the bottom. So t into t squared is just t, so I just end up with 18 over t. Okay, this is part 5. Use your answers to parts A3 and A4 to find the rate of change of the car's fuel consumption with respect to time at the instant when t is equal to 7 minutes. Give your answer in litres per 10,000 kilometers per minute. So they tell you the units here. Okay, so what we want here is the rate of change of the car's fuel consumption. So that's df with respect to time, so that's dt. So normally the way you would do these is you would write df there, you would write dt there, multiplied. So you need to put something here that will cancel out, if you like, that will divide in and give 1. So what have we got? We've got a dc, don't we, I think, from previous questions. So we have a dc here, we could put that there, that'll cancel out, and you're just left with the df dt here. So let's see, we have df dc from a previous part of the question, and that was 2.8. dc dt we've just worked out as 18 over t. So we have both of these, so let's just stick them in here. The FDC is 2.8, and then we've got to multiply that by 18 over t. So this is df dt. Now it says with respect to time at the instant when t is 7. So at t is equal to 7, we can put that in here, and we get df dt is equal to 2.8 times 18 over 7. And that will give us 7.2, and we're told the units, it's litres per 10,000 kilometers, and it's per minute. Next question. Over the first 8 seconds that Danny is driving her car, the car's speed in kilometers per hour can be approximated using the following function. So this is a piecewise function, it's in 2 parts. So from 0 to 4 minutes, you use the function 8e to the power of 0.4t minus 8. And then from t greater than 4 up to 8 minutes, you use the second function, the quadratic function there. So where t is real and it's in seconds after the car starts moving, fill in the table below to show the values of v of t for the given values of t up to t is equal to 8. Give each value correct 1 decimal place where appropriate. Okay, so I've done that already. All you've got to do really is just take each of these x values or t values here and put them into whichever function is appropriate up here, whichever part of the function is appropriate. So anything from 0 up to 4 inclusive, you're going to put it into this function here, or this part of the function. Anything from 5, 6, 7, and 8, you're going to put into this part of the function here. You should get these values. The second part of this question is just to draw that graph. So I've drawn it here. So you just go 0, 0, you go 1 up to 3.9, 2 up to 9.8, and so on. So you get this kind of a function here. Okay, so the last part of this question is then to use integration, and v of t is equal to minus t squared plus 24t minus 48.4 to find the average speed of Danny's car for t between 4 and 8. Give your answer in kilometers per hour, correct 1 decimal place. So this is an average value kind of a question. You've got v of t equal to minus t squared plus 24t minus 4, 8.4. So what we've got to do is do the average value formula, if you like. So that's going to be 1 over 8 minus 4. Our limits are 4 up to 8. Got to find the integral here from 4 to 8 of this function, minus t squared plus 24t minus 48.4, and it's with respect to t. Okay, so let's just plow through this then. 1 over 8 minus 4 is just 1 over 4. So you've got to integrate this function here. So when you integrate it, you get, let's see, minus t squared is going to become minus t cubed over 3 plus 24t is going to become plus 24t squared over 2. 2 into 24 is 12, so it's just going to be 12t squared. And then when you integrate 48.4, that's going to become 48.4t. So that's really it from 4 to 8 then. So what we've got to do then is just substitute in 4 and 8 and subtract. So let's do all of that. So we've got a quarter out here. Now we're going to put in 8 first. So it's going to be minus 8 cubed over 3 plus 12 times 8 squared minus 48.4 times 8. And then we've got to subtract what we get when we stick 4 into it. So it's minus 4 cubed over 3 plus 12 times 4 squared minus 48.4. We've got to stick 4 in there. And that is it then. Okay, so a quarter times. Right, so when you do out the first bracket, you're going to get 3152 over 15. When you do out the second bracket, you get minus 344 over 15. So we just got to do that out. So let's see, we get 874 over 15. Now we've got to, let's see, round this to, let me see, 1 decimal place. So when you do that, you get 58.3, and this is the average speed, so it's going to be in kilometers per hour. Okay, so that's really it for this question.